Hello, welcome to the eighth lecture for the Mathematics Class 11, Chapter 7, Binomial Theorem. So we are actually done with all the conceptual part of binomial theorem. So what we will do now is solve sums which are a combination of different sort of they might be a bit complicated. They will use different concepts altogether. Okay, so we will start with some of these sums. So suppose the question given to you is, just wait a moment. Okay, so suppose the question given to you is that what is the coefficient of x raised to 11 in the expansion 1 plus x squared raised to 4 multiplied by 1 plus x cubed raised to 7 multiplied by 1 plus x the whole raised to 12. Okay, oh sorry, there's a 4 over here. X raised to 4 raised to 12. Okay, so normally if you go around, doing the expansion of the individual terms and then multiplying or, getting the x raised to 11 term. Okay, so that would be a very, very lengthy process. So there are easy ways of doing it. So let's first see that the coefficient of x a. Okay, so considering this as your a term, b term, and c term. Okay, so with respect to a, you will have coefficient of x raised to a, and with respect to the b term, you will have coefficient of x raised to b, and for the c term, you will have coefficient x raised to c, such that you will have xa multiplied by xb multiplied by xc, okay, where a plus b plus c is equals to 11. Okay, so a, b, c are the power of the x, and we want to find what would be the coefficient. Okay, so coefficient of x in that form. Okay, in a form where all of these powers when added together will be 11. Okay, power will be 11 for x. Okay, so this we want to know. Now let a is equals to 2m, b is equals to 3n, and c is equals to 4p. Okay, what are m, n, and p? So actually m is the the kind of r that you will take when your expansion power is 4. Okay, so in this case what will happen is m will start from 0, 1, 2 and go up to 4. Okay, then your n will begin with 0, 1, 2, 3 all the way till 7, and your p will also take the values from 0, 1, 2 all the way up to 12. Okay, this is what we want to. So then with respect to this, where a plus b plus c is equals to 11, what we will need to find is 2m plus 3n plus 4p is equals to 11. Okay, so what are the different possibilities? Okay, so we will first find all possible cases for m, n, and p. Okay, So let's see the first case. If we take if m is equals to 0. Okay, so if m is equals to 0, and then you will get, just so what you will end up getting is 3n plus 4p is equals to 11. Okay, now you know that, 3, and suppose you take n is equals to 1 and p is equals to 1, so you will get 7. So that will not be the case. Okay, so that cannot be, that won't give you 11. So, but if you know that 8 into 3, 8 plus 3 would give you 11. Now to get 8, you need p is equals to 2 and n is equals to 1. Okay, then this will actually give you n is equals to 1 and p is equals to 2. Okay, so this is one case that we got. Now, suppose the next one. Okay, so now we know that, m can take a value from 0 to up to 4. Okay, so now let's see if we take m is equals to 1. Okay, then what we get is 2 plus 3n plus 4p is equals to 11. Okay, so this actually turns out to be 3n plus 4p is equals to 9. Okay, so when you write this, now over here, the only way you will get this as 9 is, suppose your p is equals to 0 and 3 into 3 is 9. Okay, so therefore, over here, n will be 3. Okay, then you will get 9 itself, and p, also not, p. Yeah. So p is equals to 0. Okay, so this is the second possible case that we have. Now, if we take the third one, okay, say if your m is equals to 2. Okay, now when your m is equals to 2, what you have is 4 plus 3n plus 4p is equals to 11. So that will give you 3n plus 4p is equals to 7. Okay, so 7. Now, if you take n is equals to 1 and p is equals to 1, you will get 3 plus 4, that is 7. So therefore, the combination would then be n is equals to 1 and p is equals to 1. Okay, now let's take the other one. So if you take, okay, m is equals to, say, m is equals to 3. Okay, so you'll have 6 plus 3n plus 4p is equals to 11. Okay, so that will give you 3n plus 4p is equals to 5. So this actually, there is no way that you can, get this. So there will be no combination where your m becomes equals to 3. Okay, so this will not be taken. So let's take the other one. So now the last one that we have is m is equals to 4. So when m is equals to 4, so 2 into 4, so you will have 8 plus 3n plus 4p is equals to 11. So then you will get 3n plus 4p is equals to 3. Okay, so now this is only possible if your p becomes 0, so there is no 4, and n is equals to 1. This is n is equals to 1 and p is equals to 0. So therefore, the combinations that we have are, okay, so the first combination that we had was 0, 1, 2. So you will have 0, 1, 2. Okay, so this is actually your, this would be your, say, m, n, and p. Okay, so they will be 0, 1, 2. Then you have 1, 3, 0. Okay, sorry. Then you will have 2, 1, 2, 1, 1. And the last combination that we have is of 4, 1, 0. Okay, so these are all the kind of the combinations that you can take for M and P. Okay, now when you take M and P, now you can actually find all the coefficients. Okay, where you have, M going, M taking some value, N taking some value, and P taking some value. And we have to find the coefficient of, for any time. Okay, if you actually take M and P as these values, you will get X raised to 11 itself. So therefore, the final, the part of this would be actually getting the coefficient. So you will have 4C0, okay, because we have, the expansion is, 1 plus 4, 1 plus x squared raised to 4, multiplied by 1 plus x cubed raised to 7, multiplied by 1 plus x raised to 4, the 12. Okay, so we will find the coefficients, okay, with respect to each of these combinations and multiply all of them, sum all of them together to get the final coefficient for x raised to 11. Okay, so that will be 4C0 multiplied by 7C1 multiplied by 12C2 plus you have 4C1. Okay, now the second combination multiplied by 7C3 multiplied by 7C0. Oh, sorry, 12C0. Then you have plus 4C2 multiplied by 7C1 multiplied by 12C1. Okay, and then the last one, you have 4C4 multiplied by 7C1 multiplied by 12C0. Okay, so now this will be equal to 1 multiplied by 7 multiplied by 12 into 11 into 10 factorial upon 2 into 10 factorial. So your this 10 gets cancelled. And this is 6. Then the next one would be again 4 into 7 into 6 into 5 upon 4 factorial. And this is 3 into 2 into 4 factorial. So 4 gets cancelled. Okay, multiplied by, you have 12C0, so that is 1. Then you have plus 4C2, so that is 4 into 3 into 2 factorial upon 2 into 2 factorial. So 2 gets cancelled. 2 plus this would be 7, multiplied by 7 and multiplied by 12. And the last one would be 1 into 7 into 1 again. So this will actually equal to 6. So 66 into 7 is 462. Then you have plus 140 plus 504 plus 7. So is equal to 1113. Okay, so the result is coefficient of x raised to 11 is 1113. Okay, so this is your result. Now let's do another sum. Okay. Wait a moment. Okay. Yeah. So suppose the question. Okay. Question is again a similar sum to what we did in the previous one. Okay. So what will be the coefficient of x raised to 4 in the expansion of 1 plus x squared raised to 10. Okay, now this is a form of actually multinomial expansion. Okay, so while we have not really done it, but it's a question that has been asked previously. So you can actually there's a simple formula when you have to find the different terms for such a multinomial expansion. Okay, so when you have multinomial expansions, the general term can be written in the form of tr plus 1, okay, is equals to n factorial upon r1 factorial r2 factorial, okay, and r3 factorial multiplied by your 1 raised to r1, then your b or x raised to r2, and x squared raised to r3. Okay, and now over here we have to remember that all these r1 plus r2 plus r3, okay, this is the same rule that is followed when we are doing binomial expansion, that the sum of the indices of the a b or abc over here should all equal to 10. So therefore r1 plus r2 plus r3 should be equal to 10. Okay, now over here you can see that you have x raised to r2 and x squared raised to r3. Okay, so your general term then can be written in the form of, okay, so let's mark this A. So A can be rewritten as n factorial upon r1 factorial, r2 factorial, and r3 factorial. Okay, multiply by 1 raised to r1, and this is x raised to r2 plus 2r3. Okay, because these two can be combined together. Now, see, in the question, we are being asked to find the coefficient of x raised to 4. So, if we want to find, x raised to 4, okay, so this has to correspond to x raised to 4. So, therefore, we can see, so for the needful, for the required, kind of the sum, we need to get R2 plus 2R3. Sorry, this should be equal to, okay, equal to 4. So in that sense, we will now find your, so therefore R2 is equals to 4 minus 2 R3. Okay, so now we will try to find different combinations of, again, R1, R2, and R3. Okay, so this is what we need. So different combinations of your R2, R1, R2, R3. Okay, so let's just write, say what we take for R1, we take for R2, and what we take for R3. Okay, so you have to then remember this. We have two, given conditions that R1, R2 plus R3 should be equal to 10, and you have the other one. Okay, this is your first condition, and your second condition is R2 plus 2R3 is equals to 4. Okay, so this is the second condition. Now, obviously, since we do not have any, kind of other condition, as in, how far the R1 or what should be the limit of the R1 values or R2 values or R3 values that we can take. So let's just see. So for getting 10, okay, so if you take R1 as 6, okay, so if your R1 is 6, your R2, if that is 4, okay, so 6 plus 4 can give you 10, so your R3 can be 0. Okay, now suppose you take, we can start with R3. Okay, so if you take R3 as 1, okay, so if your R3 is 1, so this would be uh, 2 into R3, 2 into 1 would be 2. Okay, so your R2 has to be 2, okay, with respect to your second condition over here. So now if you have R2 as 2 and R3 as 1, so that is 3. So your R1 then has to become 7. Okay, now let's take R3 as say 2. Okay, so if you take R3 as 2, so this will become 2 into 2, that is 4. So that means your R2 has to be 0. Okay, now if your R2 is 0 and R3 is 2, you are left with, R1 is equal to 10 minus 2, so that is 8. So R1 has to be 8. Okay, so over here we get three combinations like this. Okay, so therefore, uh, coefficient, say A would be 6 for the pair of 6 4 0. Okay, so the coefficient, as we have seen, has to be your n factorial, r1 factorial, r2 factorial, r3 factorial. Okay, so product of that. So we know that n is equals to 10 over here. Okay, so now we will get as 10 factorial upon, you have 6 factorial, 4 factorial. Okay, 0 factorial is 1, so we'll not write that. So now let's expand 10 into 9 into 8 into 7, because 6 factorial, so 6 factorial can get cancelled. Then you have 4 into 3 into 2. Okay, so now over here you can get this as, 4 twos are 4 twos are 8, so 8 2, and then this 2 gets cancelled, 3. Okay, so you get this as 2 1 10, and then the coefficient, say B, okay, for when you have 7 2 1 as your R1 R2 R3, so this can be written as 10 factorial upon 7 factorial, 2 factorial, 1 factorial. So in this, we have the highest factorial in the denominator is 7. So you can write this as 10 into 9 into 8. 7 can get cancelled upon 2. So 2, 4. So this is 360. And now you have coefficient C, which is for 8, 0, and 2. So this would be 10 factorial upon 8 factorial. So this would be 2 factorial. Yeah, 2 factorial. So now this you can write as 10 into 9 upon 2. 8 factorial can get cancelled. So you have 5. You have 45. So therefore, sum of coefficient for x raised to 4 is equals to 210 plus 360 plus 45, and that would be 615. Okay, so this is your answer. So you can see how it is easy to find, even if you have very complicated expansions with different kinds of terms with, different n's, or, combination, like over here, we can see that this is a kind of like a multinomial. Okay, so you can get it done. Okay, so let's move on to other sums. Okay, so suppose you are given, okay, for r equals to 0 1 all the way up to infinity, you have AR, BR, and CR denote the coefficient of XR in XR respectively in the expansion of 1 plus x raised to 10, 1 plus x raised to 20, and 1 plus x raised to the whole raised to 30. Okay. Then what is the evaluation of summation over R going from 1 to 10, A R, B 10, B R minus C 10, A R. Okay, so this is kind of like, you will have to simplify and then, find the evaluation of this. So over here, let A R be coefficient of X R in 1 plus X raised to 10. Okay, so that would actually be 10 CR. Then BR be coefficient of XR in 1 plus X the whole raised to 20. So you have 20 CR, and CR be coefficient of XR in 1 plus X 30 is equals to 30 CR. Okay, so this CR and this CR is different. This is the combination CR and this is the alphabetical CR. Okay, so now what we are given is you have summation over R going from 1 to 10 of AR D10 BR minus C10 AR. Okay, so this can be summation if you separate the terms. Okay, after opening up the bracket, you have AR B10 BR minus summation over R from 1 to 10. You have AR C10. Sorry, this is supposed to be AR. Oh no, this is right here. BR. Okay, so this is your C10 into AR. Okay, so this is what you can get when you separate out the terms. Now we will input the values of AR, BR, and CR. So what you get is summation of R over R going from 1 to 10. You have 10 CR, 20 C10. Okay, so B10, if we are writing, BR as 20 CR, okay, so therefore B10 would be then equal to 20 C10. Okay, anything like the R value when it is given to us, and there is the N value because it's the B term. Okay, so that is the N is going to be 20. So you have 10 CR, 20 C10, and we have BR again. So that is 20 CR. Okay. Then the next term will be summation over R going from 1 to 10. You have 10 CR. Now you will have 30 C10 in place of C10. and AR is written again. So this will be 10 CR. Okay. So this is what we get, AR C10 AR. So 10 CR, 30 C10, 10 CR. Okay. Now what we will do is, now this will become over 10. So you can write this as 10 minus R. Okay. Then you can have 20. How do we get this? Is if you write 10 CR, so that will be n factorial upon R factorial. You will have 10 minus R factorial. Okay. And if you write 10 C, 10 minus R, so you will have 10 factorial upon your R factorial, then becomes 10 minus R factorial. And you have n minus R. So this will be 10 minus 10 plus R factorial. So this actually becomes 10 factorial by 10 minus R factorial and R factorial. So therefore, your 10 CR is going to be equal to 10 C, 10 minus R. Okay, when your R becomes 10 minus R. So then you have 20 CR. Okay, we write the terms. And over here, you have summation, notation. Okay, then again, this you can convert in the 10 minus R form. You have 30, 10. Okay, and then you have 10 CR. So now we can see, okay, we will try to take this out, okay, because this is a constant and this is a constant. Okay, all the other terms you have R and over here R. So this will be 20 C10 summation of R over R, that minus R, 20 minus 20 CR, and then you have minus 30 C10 summation of R is equals to 1 to 10. You have 10 C 10 minus R and you have 10 CR. Okay, so now we can write this, okay, this entire thing in the form of 20 C10. Okay, this, if you kind of, add them up, when you have a multiplication between two combinations, you add your N and R of the C. Okay, so what you get, and this is also the summation sign also goes away because of that. So what you get is 30 C 10 minus 1, and then you have minus 30 C 10 multiplied by 20 C 10 minus 1. Okay, so if you evaluate this, what you get is 30 C 10 minus 20 C 10. Okay, and this, as you can see, this would be your C10 minus B10. Why? Because this is equals to, your CR with 30, and this is your BR with 20. Okay, so therefore your R is 10 over here, so this is going to be equal to C10 minus B10. Okay, so this is your final evaluated answer. So let's do another sum. Okay, suppose we are given that if X is positive, what is the first negative term of the expansion 1 plus x 27 by 5. Now see over here that now we are dealing with a fractional power. Okay, though we have not done it, and you don't really need to expand this entire expression. Okay, because of this different n. But if you remember, we had kind of defined your general term. Okay, so your general term without the factorial part. Okay, if you want to remove the factorial part for the n. Okay, so general term can be written as tr plus 1 is equals to, you have n minus 1, n minus 2, going all the way up to n minus r plus 1. Okay, and then this would be divided by r factorial. And if you compare, with this expansion itself, your 1 raised to n minus r would be taken out because it's 1, and you will be remaining with x raised to r. Okay, so your r is always going to be kind of a whole number, so that is fine. Now over here, when we are talking about that, x is positive, the first negative term of the expansion. So for when the negative term will come is that this part actually becomes less than 0. Okay, so therefore your n minus r plus 1 would be less than 0. Okay, so when you are writing it in this form, then this will actually mean that this is n plus 1 will be less than r. Okay, now we can put the value of n. Okay, so n is equals to 27 by 5. So therefore, we write 27 by 5 plus 1, okay, is less than r. So if you evaluate this, this will actually come up to 32 by 5 is less than r. So this would be your 6.5, sorry, 6.4 is less than r. So this in the, since we are dealing with the term, okay, the number of term or the which term that we are talking about, this has to be a whole number. So we can write that r has to be greater than 6. So if your r is greater than say 6, so we will take then that when r is more than 6, so that is suppose the first positive integer after 6 we take as 7, sorry. Okay, so now we will write tr plus 1. Okay, so the term with respect to your r is equals to 7 should be less than 0 for it to be a negative term. Okay, so the first negative term will appear when your r is equals to 7. So that means this is 7 plus 1 is less than 0. So your eighth term, okay, your T8 will be less than 0. So therefore, then we can write the result as that the eighth term is negative. Okay, it's the negative number or negative number. Okay, and it is the first negative number that would come when we are dealing with this expansion. Okay, so you see, it is easy when you have these kind of easy to evaluate and easy to remember concepts like general term of the expansion, even when we don't want to take the factorial of anything. Okay, let's take another question. You will have Q. Okay, suppose we are given as what is the positive integer greater than 1 plus 0.0001 raised to 10,000. Okay. So we have to find the positive integer, okay, which would be greater than this evaluated. Okay, so now we can write the expansion in a different form. So what would be the form? That 1 plus 0.0001 raised to 10,000, okay, is similar to the form of 1 plus 1 upon n raised to n, where n is equals to 10,000. Okay, so if you actually next one, 0. Okay, so where if you put your 10,000 in the reciprocation in the reciprocal form, then what you get is 0.0001. Okay, so you can write it in the form of this. Okay, now so therefore your 1 plus 0.0001 the whole raised to 10,000 can be written in the general form of 1 plus 1 upon n. Okay, now it is easy for us to expand this, okay, with respect to the expansion of, having the n power. So this can be then written as 1 plus, if you remember, we had done the general kind of expansion of, say 1 plus x. Okay, so if raised to n, so you have 1. Then if you have n by 1 factorial, okay, and then you have x n minus 1, okay, in that form we can write. Okay, so over here, similarly, we can get this as n into, now your B will come. Okay, so your A is going to be 1. So anything raised to 1 raised to anything is going to remain 1. So we will not write it. So we'll focus only on the B, the term that is there in the B position. So now this will be B raised to 1. So this will remain as 1 upon n. Then the next term would be n minus 1 upon 2 factorial. Okay, and this will be b squared, so 1 upon n squared. Then the next one would be n minus 1, n minus 2, okay, upon, now this would be 3 factorial, and you will get 1 upon n cubed, okay, and then plus and so on. So now if you evaluate this n and this n gets cancelled out, okay. And over here also, this n and 1 n over here will get cancelled out. So what you are getting is 2 plus, over here you will have n minus 1, 2n, okay. And then the next one you can have, you can have n squared n. So now what you get is n minus 1, n minus 2, the whole raised to 6 multiplied by, so you will have n squared below. Okay, so similarly all these. Now over here you can see that all the other terms can, be written in the form of a positive quantity. Okay, because we have mostly everything positive over here, and even the, sum over here is actually, either positive over here, sorry. So this will be 2 plus a positive quantity. So therefore, we can say that 1 plus 0.1, the whole thing raised to 10,000 is actually greater than 2, and therefore the 3 will be greater than. Okay, so we are being asked which positive integer. Okay, so the next positive integer would be 3. 3 will be greater than the expression that we are being asked, that is 1 plus 0.0001 raised to 10,000. Okay, so this is your going to be your final answer. Okay, now let's take another example. Suppose you have okay, so suppose the next question is question if the sum of coefficients in a plus b the whole raised to n is 4096, then what is the greatest coefficient of the expansion? Okay, so this is the first step that we will have to do, is that we have to find the value of n. Okay, so when we find the value of n, we can find which term will have the greatest coefficient. Okay, and then we can get the answer. So if you have a plus b the whole raised to n, okay, so expanding it, what we will get? N C0 a raised to n, b raised to 1 plus n C2 a n minus 2 b raised to 2. Okay, and all the way up to your n c n b raised to n. Okay, so this is what we have. Now, all these coefficients, okay, so all these coefficients, if you just write them in terms of some variable, okay, so this can be written as C0, then you can have C1A n, n minus 1B plus C2 a raised to n minus 2 b raised to 2 plus all the way up to cn b raised to n. Okay, so where C0, C1, C2, all the way up to Cn are the binomial coefficients. Okay, so suppose, okay, for example, we take let a is equals to 1 and b is equals to 1. So therefore, we can write that a and b both are 1, so the sum of them will be 2. So 2 raised to n is going to be equal to c0 a raised to n. Okay, and now over here you have c1 a n minus 1 b plus all the way up to your cn b raised to n. Now, since your a and b are 1, okay, so all these variables, okay, a, b variables, all of them would take the value of 1. So therefore, this can be then written as C0 plus C1 plus C2 plus all the way up to your last coefficient. Okay, so therefore, now we have already given the condition given to us that the sum of the coefficients in this expansion is going to be equal to 4096. Okay, so then what we can write is that 2 raised to n is going to be equal to, okay, so the sum, we can see that 2 raised to n is the sum of all the coefficients. So 2 raised to n is equals to 4096. Okay, now as we can see that the last digit of this number is going to be 6. So if we we first try to take the square root of this. Okay, so the square root is actually going to become 64 into 64. Okay, now 64 itself is again squared of 8. So you can write this as 8 into 8. We have to find n. Okay, so let's try to get this 4096 in the form of 2 raised to something. Okay, so 64 into 64 can be written as 8 into 8 into 8. Okay, so now 8 is actually cube of 2. So this then finally becomes 2 cube multiplied by 2 cube multiplied by 2 cube multiplied by 2 cube. So this then will give us 2 raised to 12. Okay, so 2 raised to n is equals to 2 raised to 12. So therefore, the first part of our problem is that where we had to find the value of n, we get n is equals to 12. Okay, so now when n is equals to 12, okay, so we know that for any n, the total number of terms is n plus 1. Okay, so for even n, there will be odd number of terms. Okay, so when you have odd number of terms, okay, so there will be one single term in the middle of the entire expansion, which will have the greatest coefficient, which will have the highest value of the coefficient. Okay, so odd number of terms. Okay, so therefore the middle term of even n expansion will have the greatest term. Okay, only with respect to when we have, we are taking a plus b, and in that over here we'll see that a is equals to 1 and b is equals to 1 we have taken. Okay, because if you remember, so suppose when you have say a plus b raised to 4. Okay, so if you remember, you have a raised to 4 plus 4a cube b plus 6a squared b squared plus 4ab cube plus b raised to 4. So this is the middle term, and you can see that this has the highest coefficient compared to all the terms on its left and right. Okay, so therefore, if your n is equals to 12, okay, so your r for middle term will be 12 by 2 is equals to 6. Okay, so therefore the coefficient of the greatest term is equals to 12 6 12c6. Okay, so now if we evaluate this, so you will have 1 6 factorial, and we will expand the other 6 factorial, so 6 into 5 into 4 into 3 into 2. Okay, so the numerator part we can write as 12 into 11 into 10 into 9 into 8 into 7 into 6 factorial. Okay, so 6 factorial can get cancelled. 6, 2, 2, 2, 3, 3, you have 4, 2, 5, 2. Okay, so then when you evaluate this, the final answer would be your 11 into 2 into 3, so 22, 66, 66 into 2. So this will be actually come up to 924. Okay, so this is your final answer. So you can see, even though that, the question seems a bit complicated, and, it's not directly given to you, you can use the logic. Okay, wherever you possible, we try to simplify it, or we can, expand it when we are given, anything with raised to n, and then we can substitute either with the general term that is being asked, or if we can understand which r we need to find. Okay, so then it becomes easy for us to solve such kind of sums. So today we will end here. So thank you for attending the class.